Hi everyone. Today I'll talk about nucleophilic addition reaction of H2O, which is also called hydration. So for nucleophilic addition reaction of H2O, there is a two-stepwise mechanism, one which is base-catalyzed and one that is acid-catalyzed. So let's start with the acid-catalyzed. So in a nucleophilic addition reaction, we know that the electrophile has to be a carbon in a ketone or an aldehyde because both of their leaving group, whether it is a carbon or an R as a carbon chain, or it isn't, whether it is an R or a H, we know that they are both a bad leaving group, so they are going to stay and form a final product, which is a tetrahedral product, which is in this case in an hydration reaction, it's going to form an hydrate product. Thus, it's also because it says it in the name, a nucleophilic addition. In addition, it's the replacement of a pi bond, so a double bond, with two sigma bonds. So it's the addition of two atoms in this reaction. So first off, we will start with the hydration reaction with an acid catalyst. The reason we need this acid catalyst here is because H2O, as our nucleophile, is a weak nucleophile. And because this electrophile here, this carbon, is also a weak carbon or weak electrophile, because this R group, this carbon, doesn't really like electrons. It is not very electronegative. So this carbon is surrounded by a decent amount of electrons, so it is not super electrophilic. It is not super electron deficient, if you want to say it like that. So because of that, we need to use this acid to protonate this oxygen here, which will then create a resonance, and it will give this carbon a formal positive charge. So first step here, with a weak nucleophile, we protonate this oxygen. So what happens is this oxygen receives this hydrogen, forming a positive charge, but there is a resonance structure here, which gives us, if we roll this pi bond up top, forming two lone pairs, we then have a positive charge on that carbon, which makes it a strong, much stronger electrophile and ready to be attacked by water, which is our nucleophile. So in this case, we would then have water attack the carbon, giving us this intermediate, and then we would use a base, we can use water, to deprotonate this here to take the positive charge away. So we start again at the bottom. So if we follow the arrow pushing, now we brought this lone pair back, or we brought this bond here as a lone pair. So now our oxygen is back with a neutral charge. And now we have our hydrate product. So this is relatively simple. This is the stepwise mechanism for a nucleophilic addition reaction of water with an acid. Being acid-catalyzed. So this is for acid. Let's now do the exercise with a base. So now, remember we said that anions are strong nucleophile, and we know that now this is an aldehyde, so it will form a tetrahedral product. So within an ion with a strong nucleophile, the first step is the nucleophilic attack. Now, the only thing left to do is, in the presence of an acid, it could be this, or it could even be water. We would have this this negative charge attack the hydrogen to then protonate this oxygen. Leaving us with our hydrate final product. So remember to first off locate your electrophile, whether it is a ketone or an aldehyde. Now after that, you know that you're doing nucleophilic addition reactions, and whether your first step is protonation or nucleophilic attack, make sure to look at your nucleophile and see how strong it is. All right, I hope this helped, and thank you for watching.